This video is about physical properties. What are physical properties? Let me give you a definition. And here's my definition. Physical properties, those are characteristics that can be measured without changing the subject into a new substance. So by subject, I mean whatever you're looking at, whatever you're trying to measure, and new substance means no chemical change. So if a physical property can be measured without a chemical change happening. So normally when I make my videos, I like to put in as many pictures and things as I can, so it's not just words on the screen. You get to actually see stuff. But I went out and I got this list of physical properties off of, I think it was about.com. I just typed in physical properties list, and I got this pretty big list. And I'm not going to do all these in this video, otherwise it would be enormous. I'm just going to focus on some of the key ones that you're likely to see in my class. And I'm going to show you pictures where I think it's a good idea. And then if I feel like I'm dragging out way too long, then I'll probably stop doing that part way through. Well, anyway, let's see what happens. So beginning with absorption. What do you think of when you think of absorption? I think of a sponge absorbing water. Typically, science people, when they think of absorption, they think of light being absorbed into something. So how much light goes into something and doesn't get out, that would be a good definition of absorption. One that I'm going to focus on a little bit more is area. Area is interesting because that's the size of a surface. And of course, you can measure the size of a surface without changing whatever you're measuring into a new substance. So area is a physical property. And if you have a nice rectangular surface, then area is just length times width. So one thing to remember about area then, if you're doing your length in meters and your width in meters, when you multiply them together, you're going to get meters squared. Do not let that frighten you because it's just a little squared in the unit. I've had kids come up to me when they get to the pressure area quiz or whatever, and they say, am I supposed to square my answer because this little 2 is here? And I say, no, that's just part of the unit, because to get that unit, what you did was you multiplied a length in meters by a width in meters. So no, you don't have to do anything special with that. Okay, so let's see, brittleness, it's what you would expect. Some things, when they break, they tend to be brittle, like a glass, like right here, or certain plastics, or even certain metals. Certain metals are brittle, like this shattered bolt right here, or this plumbing fitting. So brittleness is tending to shatter. That's how they break. Boiling point. Boiling point, very useful in this class. That's the temperature where something goes from a liquid to a gas. So I'm going to write temperature where liquid goes to gas. That's the boiling point. And for water, it's 100 degrees Celsius. And for different chemicals, they have different boiling points. Let's see here. Nail polish remover boils at 56 Celsius. Water's at 100. Alcohol boils at 78 Celsius. We talked about that already with the separating chemicals video. Olive oil doesn't boil until you get up to 300 degrees Celsius. So there's another one. Capacitance, we're going to skip in this class. Color. I don't think we need to write a definition for color, but you can identify, or I'm sorry, you can measure the property of color without changing the substance into a new substance. You're like, hey, look, that kid's wearing a red shirt. Okay, you didn't change the red shirt into anything else, so color is a physical property. Concentration. Concentration. Useful in physical science. Concentration, here's my low-tech simpleton definition. And here's what I wrote. I wrote concentration is how much of one thing is dissolved in another thing. Typically, we're talking about liquids when we're talking about concentration. By that, I mean, let's see here. You know, you've got a lot of salt in some water, or you've got a little salt in some water. So if you have a lot of salt in the water, you have a high concentration. If you have a little salt in the water, you have a little concentration. So two terms that go along with concentration then, whatever the liquid is that's doing the dissolving, we call that the solvent. And whatever it is you're throwing in, you know, a salt cube or a sugar cube or whatever, that's called the solute. So the solute goes into the solvent and it gets dissolved. Next term on the list, trying to go as fast as I can. Density. Density, interesting term because it's a ratio. In other words, it's one thing divided by another thing. And density is a ratio of mass to volume. So mass we usually measure in grams or kilograms. I'm going to write grams. And volume we usually write in maybe cubic centimeters. So another way that you could do this is you could have kilograms per cubic meter. But the key is that you have a volume on the bottom and a mass on top. So whenever you see a density, you're going to have this combined unit, and that should ring a lot of bells for you because it's you know, it's not the same thing as, but it's kind of like speed. Speed is a ratio of distance to time, you know, miles per hour. You've seen that sort of stuff before. Next term on my list, ductility. Ductility, that is a metal's ability to be drawn out into a wire. So here's something on density that I should have shown you, but I didn't. Okay, ductility. Let's see here if I go to images. Certain metals can be drawn out into wires and other metals can't. If you're a wire that can be drawn out in, I'm sorry, if you're a metal that can be drawn out into a wire, then you are said to be ductile. So there's my definition, can be drawn out into wire. Okay, one page down, almost 7 minutes in. That's kind of scary. Alright, so for this page I'm just going to blast through. Maybe we'll end up, if we show this in class, end up pausing it or something. So let's go through this. Electric charge. Is it a positive charged object or negative, or does it have no charge? These are things we can measure without changing something into something else. So that's why electric charge is a physical property. Electrical conductivity. Does it let current pass through it or not? Metals tend to let current pass very easily, so they have a high conductivity. Non-metals tend to not let current pass, so they tend to have a low electrical conductivity. Electric potential. That's the way that I think of voltage. That's how much electric push there is. The more voltage, then the stronger the electricity is pushing through something. Flexibility. Don't need to give you a definition there. You know, a piece of paper is flexible. Frequency. We talked about this last semester when we were talking about waves, but frequency is how often. Like 2 heartbeats per second. Remember, we measure frequency either in per second. It's the same thing to say hertz. Length, location, luminance. How much light does something give off? You know, the sun has a certain luminance. Luster. Luster is another word for shine. Usually we're talking about metals with luster, but we don't have to be. Malleability. Once again, we're usually talking about metals here, but malleable things are able to be shaped. Like aluminum can be made into aluminum foil or wire, so it's also ductile. But if something is shapeable, we call it malleable. Magnetic field, you know, is there one? Isn't there one? How strong is a magnetic field? These are things we can measure without changing the substance into something else. Mass, very important in physical science. Mass is the amount of matter in something. It's not just the scale reading, it's actually how much stuff is in something. We measure it in grams or kilograms. Because remember, here on Earth, when we throw something on a scale, we're actually measuring weight, which depends on gravity. But the amount of stuff in something, the mass, doesn't depend on gravity. It's just a number. It is what it is. You know, if you take me out in space and put me on a scale, it would read 0 because there's no gravity there. So anyway, next page. Okay, last page. Melting point, that's the temperature where a solid becomes a liquid. Different substances melt at different temperatures. Momentum, well, this was in the first semester. That was mass times velocity. Pressure. Pressure is another one of those ratios. It is force divided by area. You can measure how much pressure something puts on something else without changing it into something else. So pressure is a physical property. Solubility. Does something dissolve in something else or not? Salt will dissolve in water quite easily, but will it dissolve in olive oil? That's a solubility question. So key there, solubility, dissolve. Just look for those, word roots. Let's see. Specific heat. There is a quiz in this semester called Specific Heat, and specific heat is a rating of how easy or hard it is to heat or cool something. For example, water has a super high specific heat. It's very, very hard to heat water and very, very hard to cool water. Most metals, like aluminum, have very low specific heats. It's very, very easy to heat or cool aluminum. So we use these types of things, specific heats, when we're making engineering decisions about what materials to use for what purpose. Temperature. You probably haven't thought of temperature this way, but a temperature is a measure of average particle motion. So if you have a glass of water with a high temperature, that just means that the particles in that glass of water are really bouncing around fast, all over the place. Thermal conductivity. How well does something let heat pass through? If something has a high thermal conductivity, then it lets heat pass through very easily. If something has a low thermal conductivity, then it doesn't let heat pass through very easily. We call those things insulators. Velocity, that's an old term from first semester. Velocity is speed with direction, both things that you can measure without changing into a new substance. And then finally, volume on my list here, trying to finish before 12 minutes. Volume is a 3D size, and you've got to have a length, a width, and a height. And I didn't label those very well, but when you multiply them together, what you're going to get is some kind of a cubed unit, maybe cubic meters or cubic feet. And one more time, because some kids freak out when they see these threes, you don't have to cube your answer. That's just the unit, cubic meters and cubic feet. So there's my video on a bunch of physical properties and descriptions, and I'm done.